So, good morning, everybody. I will continue on the chapter about age and sex composition. And we finished the previous class talking about how understanding changes in age and sex composition of different countries and populations can help us make some predictions to the future, and how previous historical patterns of age and sex composition help us understand what's going to happen in the coming years. So different demographers have been trying to understand these overall patterns that change over time, but they have some sort of regularity that help us project how our population is going to be. And then I mentioned these marriage patterns by age, developed by Cole, and I'm saying that people get married in specific age groups around the beginning of or in their early ages of their reproductive time, like so around 20, 24 years of age, and how that has been changing over time. And these patterns also vary by sex, usually men marrying at older ages than women. Luis, and here he described fertility patterns by age on the absence of voluntary fertility control to try to understand how family planning programs have an impact on how many children women have, right? I mentioned also these mathematical models by Andre Rogers, who was a professor at the University of Colorado Boulder, and he tried to create a mathematical model to summarize the migration rates by age, because the migration rates by age, as we saw in previous slides, can have a really complicated curve with higher levels for children that kind of mirror the levels of migration of their parents. People, when they move to get higher education or get jobs, their chances of migrating is really high. And as people get older, their chances of migrating decrease a lot. But if you get this curve here of migration rates by age, it's difficult to summarize it. So he pretty much tried to come up with a mathematical function that would estimate a series of different parameters for each portion of this curve. And another interesting thing of his model is that migration is kind of like a rare event. For example, right now in the US, less than 10% of the population migrate from one country to the other every year. So migration this curve here can have, if we just look at the observed migration rates, it can oscillate a lot. So instead of being so smooth like this, these rates here, they can oscillate a lot from one age group to the other. So what the mathematical model does, it smooths this curve, okay? So whenever we are talking about mathematical models, not only migration, but fertility and mortality, we are trying to first correct the data that has so much oscillation because of being rare events, small sample size, but also to better understand regularities over time, okay? And really interesting theory that demographers came up with is the stable population theory. So this is one of the most utilized theories by demographers, and it incorporates a population age and sex structure, specifically age structure, trying to understand what's going to happen with the population in the next decades in terms of size, in terms of composition by age and sex. The stable population theory, whenever we're talking about the stable population theory, the analysis is done without considering migration, right? So if we are talking about, we are trying to project what's the composition of the American population is going to be in the next 10, 20 years. So with the stable population theory, we do take into account fertility rates, we do take into account mortality rates, but we do not take into account migration to the US and immigration from the US to other countries. When we do not take into account migration in our analysis of demography, we say that this analysis considers a closed population. It's closed population because I'm taking into account only mortality and fertility, not considering migration. Migration, as I just said before, it oscillates a lot from one age group to the other because it's a rare event in our population. And it also can change a lot from one year to the other, right? Because of a specific policy that a federal government institutes. It can prevent people from moving into the country. During the pandemic, we start to see many more requirements for people to move from one country to the other. So migration oscillates much more due to responses to public policies and to economic well-being of the population than fertility and mortality. Of course, people start to have fewer children when unemployment rates increase a lot, but overall, migration is much more responsive to daily changes in our society than fertility and mortality. Fertility and mortality have declined a lot, and they're kind of stable over time, but migration still oscillates a lot. So when we are trying to do a first exercise to think how population is going to be in the future, we usually consider it a closed population. But then afterwards, we have to include the migration, some migration simulations in our analysis by saying, oh, what about if immigration to the US continue the same as now? What about if they decrease or if they increase? We have to do some realistic simulations of what we think immigration and immigration is going to be. But overall, the stable population theory considers the analysis of thinking that that specific population has no migration into that area and no migration to outside of that area to other areas. So if I'm doing the projection of the world population, that's okay. There is no migration, right? At least right now, there is no migration between planets. But if I'm talking about population of the US, yes, there is migration between countries. But for this exercise, migration is not considered. The whole idea of the stable population theory is that fertility and mortality, they change in these last decades, in these last centuries, right? Fertility declined a lot. Women are having fewer children now. And some countries still keep going down because it's expensive for women, for families to have many children. So still fertility rates are going down. But overall, fertility rates, they kind of fluctuate a little bit, but they are around 2 children per woman. If you watch that video by Hans Rosling, that public health researcher, that when he made that video about basic demographic trends over time, he kind of said, oh, demographers, they are really careful by saying that specific countries have higher levels of fertility, lower levels of fertility, but overall, we have fertility around 2 children per woman. Of course, some countries have really low and some countries have higher. Some Asian countries have really low fertility and some African countries still have higher fertility. But overall, fertility has been stable over time. Even for those countries with high fertility and the ones for low fertility, stable fertility doesn't change as much. Mortality, the same thing, right? Mortality declined in these last decades and these last centuries because of improvements in public infrastructure, sanitation, water treatment, also because of vaccines and medication and everything. So mortality declines in all medical technology and so on. But right now, we saw an oscillation because of the pandemic. Life expectancy at birth in the US declined for more than 1 year, as we're going to see in the mortality chapter or in the next chapters, for more than 1 year because of the pandemic. But overall, the levels of mortality don't change as much. So because fertility and mortality rates are kind of like being stable over time, there is some fluctuation, but there is some stability over time. If we think the chances of having children and the chances of dying for each one of the age groups of people are kind of stable over time, we can predict how the age and sex composition of this population is going to be. So what I'm saying about for specific age groups, if women between 20 and 24 years of age in these last decades and the following one, they continue to have the same chances of having children. Women between 25 and 29, between 30 and 34. The same thing for mortality. If people are dying at the same rates for all these age groups, our population will develop a constant age distribution and will grow at a constant rate. It doesn't matter how the age and sex distribution was before. Overall, if more people are being born than dying, but fertility and mortality are kind of stable, but if birth is higher than deaths, then population will grow at a constant rate. Again, if mortality and fertility are stable over time, but the number of people dying in the country are higher than the number of people being born, then the population will decline at a constant rate. Okay? So demographers sometimes indicate that these stable populations, they forget their past. And we will have either a decline in the size of the population or increase in the size of the population, depending whether births or deaths are higher than the other, but we will have a constant age and sex distribution in percentage terms, right? The percentage of people by age and sex, age groups and sex will be constant over time. Overall, what demographers understood from empirical analysis is that the age distribution of stable populations depends on the underlying age-specific mortality rates and the rate of growth. So it's pretty much how are the age-specific mortality rates moving over time. If the age-specific mortality rates are constant, again, what is the age-specific mortality rate? The chance of dying for each specific age group, the chance of people dying before reaching age 1, the chance of people dying between ages 1 and 4, between 5 and 9, and so on. And the overall rate of growth, the overall differences between overall number of births and deaths. More births, increase. More deaths, decrease. But the age structure, age-sex structure will tend to be constant over time if the population experiences constant age-specific fertility and mortality rates for a long time, for several generations, right? The stationary population is one specific kind of the stable population. The stationary population is a stable population in which the number of births, the birth rate equals the death rates. The same number of people being born in the country, the number of people being born in the country equals the number of people dying in the country, right? This results in no change in the size of the population. There are three kinds of stable populations, right? The stable, the one before here, the stable population. Births higher than deaths, population grows, constant rate. Deaths higher than births, population declines at a constant rate. Birth and death equal, population will continue with the same size. This specific kind here is called a stationary population. In all three of them, the age and sex structure will tend to be constant over time. In the first one, population, it has a similar percentage of people in age and sex groups, but the population increases, population declines, and the stationary population, the size of the population doesn't change. And again, it's with the same hypothesis, the same assumption of a closed population, not taking into account migration. If we are doing this for a country, and the country has more immigrants than immigrants, of course, the population will increase in size. If this population has more immigrants than immigrants, the population will decrease in size. But for the exercise of stable population, specifically for stationary, we don't take into account migration. And what I mentioned to you in the last class was this tweet by Elon Musk, in which he was criticizing the projections, the population projections done by the United Nations, right? All these projections that I have here in my course that goes up to 2050, 2100, they're all from the United Nations, or most of them are from the United Nations. And he's criticizing it by just saying, oh, instead of doing all those difficult population projections that the UN does, this is an easy exercise. Just multiply the number of people who were born in the last year by the life expectancy. And what is the life expectancy that I already mentioned in the course here? We get the age-specific mortality rates of a population in a specific year. So the rates of the chances of people dying below age 1, between 1 and 4, between 5 and so on, until 85 plus. And let's expose a hypothetical cohort that would experience those mortality rates throughout their lives. See that now I'm 44. I'm exposed to the chance of dying for the age group between 40 and 44. When I reach 54, my chance of dying will not be the one of people 54 right now in the US. Will be of people 54 10 years from now. So the life expectancy is getting the age-specific mortality rates for the population, a specific population, in 1 year. No real person will experience those rates throughout their lives, because as they get older, mortality rates change. So what the life expectancy is the result of is, let's get this age-specific mortality rates for a population in a specific year, expose a hypothetical cohort into them. If a hypothetical group of people were exposed to these mortality rates, how many years on average would they live? That's the life expectancy at birth. So the life expectancy at birth is not a measure of a real population. It gives us an idea of the level of mortality of one population in a specific year. And he's saying, oh, just get the life expectancy at birth, which summarizes the information about mortality in a specific population 1 year, and multiply by the number of births. And then you know what's the size of the population in the future. So it's pretty much of saying, oh, demography is really easy, right? Just multiply one number by the other, and let's move on. And all these tweets in response to Elon Musk are from Professor Kashnitsky from the University of Southern Denmark. And his main basic point is, no, that's not so easy to do population projections. Why am I bringing these tweets from Elon Musk about population projection of multiplying number of births and life expectancy at birth when I'm talking about stable population? Because that's pretty much what he's suggesting. He's pretty much saying that the life expectancy at birth, which is a summary of mortality rates, will be constant over time. And he's saying that the number of births will be constant over time as well. Then He's just multiplying one by the other. He's getting this total size of the population, but with the assumption that there is no fertility changes, there is no mortality changes, there is no migration. So he's not doing any further exercise that's necessary to do in order to do population projections. And it was interesting that Kashnitsky, he did the exercise. I mean, I just think these guys are so good. I mean, the same day he already implemented what would be the proposed methodology by Elon Musk and comparing it to data from the human mortality database. So he got data from the human mortality database and look at the population from like around the 30s and 40s up until now, and then compared to this exercise proposed by Elon Musk. And what he sees is this projection by Elon Musk, it's really not reliable, right? It's the mortality in his assumption has a much lower level on punishing the population and also much higher fertility than the actual size of the population from the human mortality database. So the difference between the red and the black lines, it's pretty much showing how wrong would it be to just use the simple exercise of a stationary population to do the projections. We understand how the population is going to be in terms of structure using the stationary or stable population theory, but we have to go further. We have to make some assumptions of how fertility is going to be, how mortality is going to be, how migration is going to be, okay? And he kind of like just reminded of a tweet that he had sent, even was like last year, that he was explaining what life expectancy is. If there is just one take-home message from this thread, let it be, life expectancy is a snapshot of the current mortality. We get the age-specific mortality rates of a population in a specific year, right? For each mortality rates for each one of the age groups. It's not it's not a projection of the actual experience of newborn cohorts. We are not following people over time. Right now, I'm exposed to the chance of dying for the age group of 40 to 44. 10 years from now, from 50 to 54, if I'm still alive. But 50 to 54, the mortality rate right now in 2022, it's not the one that I'm going to be exposed to, because the chances of dying and having children change over time. This researcher from the Max Planck Institute in Germany, so he's pretty much saying that what Elon Musk is suggesting is a stationary population analysis, right? He's pretty much just suggesting projecting the population of the world. Why the population of the world? Closed population, zero migration. There is no interplanet migration at this point in our history, right? If we look at different countries, as we want to know population projects for each country, we have to take into account migration. In this exercise here, he's not using migration. It's stationary because birth rates equal death rates for several generations. So he's just using the same number of births and the life expectancy over and over to try to project how the population is going to be in the future. Right? So this suggestion here is just using the stationary population assumption. And mortality remains constant, while in this suggestion here, birth rate is allowed to decline, right? Because there is a decline in fertility in this last year because of the pandemic. One of the factors is the pandemic, right? There are other factors as well. But yeah, if you just multiply number of births by life expectancy at birth is 0, you do get the overall size of the population. The problem is with the assumptions. The closed population, no migration, mortality and fertility constant over time, that's not feasible. No migration is not feasible between countries if you are doing the analysis for each country, right? So it's just interesting because I follow different, in Twitter, I pretty much follow politics in the US, Brazil, and demographers. And demographers, when this tweet came out like 2 weeks ago, they got crazy and everybody tried to, we're making jokes and criticizing this because you're just pretty much, he is so powerful because of having so much money and pretty much saying that these UN projections are not valuable, but they are. And his audience is much bigger than mine and than any other demographer. And it's just crazy how someone so powerful in terms of reaching out to people can make such a serious claim and undermining such a serious institution like the United Nations that try to be really careful in projecting population over time, because that's important for policymakers. It's important for us to understand how our society is going to be in the future, right? And then he did the same exercise for several countries on the left. As I said, you cannot read that, but if you download the presentation, you can zoom in and see each one of them. On the right-hand side, I just zoom in for Taiwan, Russia, and USA. In this previous graph here, he showed how the population was measured by the Human Mortality Database. And here, using this method suggested by Elon Musk. In these graphs here, he pretty much just get this number and divided by this number. He gets the red and divided by the black. And gets the black and divided by the black. When you get the black and divided by the black, it's 1. Multiply by 100, 100%. So this one here is the actual population over time, the black. The black divided by the black. The red, Elon Musk divided by the actual, red divided by the black, is these curves here. So you see these examples, how for Taiwan is completely off, much higher in years prior to 2020, and much lower in more recent years. Russia also oscillates a lot. The US always overestimating, as we saw here before, right? This overestimation here is showing a different form in this graph, okay? In other words, demography is not so easy as multiplying one number by the other. You have to understand what the measures are. You have to understand what life expectancy at birth means. You have to understand how the age-specific mortality rates were calculated, how the whole life table, that's that technique that we use to estimate the life expectancy, all these steps are done to understand it, and then have an idea how the age-sex structure of your population is going to be. And then you add to that simulations of how you think fertility, mortality, migration is going to be in the future. These simulations of how you think fertility, mortality, and migration will be in the future has to be based on previous research, on historical data. If you just take some simulations that are not reliable, not realistic, your projections will be really off when you compare to real data 10, 20 years from now. So you have to have some historical analysis based in your simulations, so your simulations are realistic in a way that your projections 10 and 20 years from now are close to the real size of the population that will be in the future, right? Cool. I just thought it was really interesting that he sent this tweet right at the beginning of the academic semester, and I was going to talk about stable and stationary populations, and I thought about bringing it here to the classroom. A simple exercise to show the age and sex structure of the population, graph to show the age and sex structure of the population, is popularly known as the population pyramid. I'm sure you guys all saw that before. You probably learned how to do in high school. And it's pretty much just a graphic representation of the age and sex structure of the population. So it's called age-sex pyramid as well. But due to the recent changes in population, because the age-sex structure of the population used to have this shape, right? A lot of children being born and people not living too much. So the percentage of people in older ages is smaller than children. But as fertility declines and people live longer, the age-sex structure starts to change, be more rectangular. So because of that, this term population pyramid is not completely appropriate right now if you're analyzing populations for more developed countries, for example. So that's why we usually call it age-sex structure or graphical representation of age-sex composition, right? So pretty much what you have to do is do a graph in which it's a bar graph, right? On one side you have men and the other side you have women. And each bar is one age group. And you have positive and negative numbers in your software. And you input the data. And then you can look at changes over time. They represent male and female populations on each side. Usually demographers use either one age group, or single age, or 5 age group. But actually for developing countries, the data is not so reliable for each specific age. So the age-sex structure, the graphs are usually done for 5-year age groups. And a main characteristic of age transition is a change from very young populations into an older population, as I mentioned before, okay? These slides here I got from this website, populationpyramid.net. You can go there and download your own age-sex structures for a specific country, and it has for several years. Right now here, I just got it for the world for specific years, but you can get for every single year for all different countries in the world, right? And you can just download them. So for the world, the population in 1950 was around 2.5 billion people. And the age-sex structure, in this case, is shown in percentage terms. You can also have the numbers here in the horizontal axis as absolute numbers. But here in this case, we show in percentage, so you can look at the percentage changes over time. If you put absolute numbers, when you look over time, you'll be looking also at the population just getting bigger, all right? But in this case, we want to understand the structure, the proportional structure, not the size. So that's why it's in percentage terms. So here, you have men between 0 to 4 years of age. They were 6.8% of the population, women 6.5%. And remember, sex ratio at birth is usually above 100. What is sex ratio at birth? You get the number of boys being born in the country specific year, divided by the number of girls, and multiply by 100. So usually you have more boys being born than girls, usually 105. And because you have more boys being born, you usually have more children from the more boys between 0 and 4 years of age than girls. Back in 1950, mortality was still really high, so a lot of population loss happened in the previous decades. So really low percentage of people in older ages, really a pyramid shape, in this case, the age-sex structure. 2000, the base of the pyramid here is not so wide anymore. It shrinks a little bit. And then 2020, it starts to get a little bit more homogeneous from the younger age groups until the age groups of 30 to 35, 39, for example, 35 to 39. And here the world population with already around 7.8 billion. And then projections for 2050, population around 9.7 billion, and much more rectangular shape, the age-sex structure. And by 2100, even the number of children proportionally smaller than people in labor ages, for example, in each one of those other age groups. And here is a pyramid for France, and it's for every single age. So France has really reliable data. So you can look at the age-sex structure, not by the 5-year age groups like we had in the previous graphs here, but for every single age, right? From 0 to 105. So really refined data. And you have, in this case, the overall size of the population. Like I said, the horizontal axis can be the absolute number, not just the percentage number. So here we have population in thousands. And with a simple age-sex structure of France from 2006, you can see a little bit of the history of France in this graph. So you see here you see on where it's marked here by 1, that these groups here are much smaller in size than some people little younger than they are. So these people here are smaller than the people just a little bit came after them. That's due to the birth deficit due to World War I. So exactly because you had lower fertility during World War I, these people who were born around World War I, they were a smaller cohort. 2, the depleted cohorts reach reproductive age. When these people here, who were born during World War I, when fertility declined, when they reach reproductive ages between 15 and 49 years of age for women, they are a smaller group in absolute number, in size, overall size. Since they're a smaller group, they will, even if they maintain the same fertility rates as previous generations, even if fertility doesn't decline, you will have fewer children. They will have fewer children than previous generations. So these guys here on 2 are the children of these ones here. And then again, World War II on 3 is the birth deficit due to World War II. And after World War II, when you start to see economic development in Western European countries, in the US, and people are more optimistic about life and get married, have more children, we have the baby boom, increase in fertility. You see on here marked by 4, right? And then you start to see again a decline in the number of people after the end of the baby boom. People have this increase in fertility rates right after the World War II, and a few decades later, fertility declines again, okay? Like in the late 50s, early 60s, it starts to decline again, okay? One graph, really simple, population of men and women by age, in this case by single age. We can see some of the historical events that happen in France just by looking at these differences from one age group to the other. With a 5-year age group, it would be harder to see this. With like 1-year age group, we can better see these changes, this smaller number of people in specific time points, as we saw here, here, and here, okay? Uh, Also examples of population structure for 2010 and projections for 2050. For India, 2010, really high fertility, still a pyramid shape. And then it starts to have a more rectangular shape, but it's still much like in terms of, even in this case here, absolute number, population in millions, much smaller in older ages than younger ages. But as these people here get older beyond 2050 and mortality rates decline, they will reach older ages with higher chances. And then these bars here will also tend to increase, right? Will tend to be wider. Population structure by sex and age in China. And you see by 2010, you see a huge difference in the number of children from people between 20 and 24. Economic development and the one-child policy in China, one-child policy implemented between 79 and 2013, but also economic development influenced the decline of fertility. Even with the one-child policy, the total fertility rate in China during the policy was around 2 children per woman. But still, that was a huge decline compared to historical trends. And then you generate this difference in the size of younger cohorts to older cohorts. And as people get older, you start to see actually a bigger number of people in older ages than younger ages. So as these people get older, which is 60 to 64, and then 10 years from now, 70 to 74, 80, and so on, because mortality is declining, people live longer. What's going to happen? Older people are usually retired, and then they will put a pressure, a demographic pressure on those people who are in working ages. And people in working ages don't have as many children to sustain, but then we're going to have a retirement system needing a lot of resources, because overall you have all these older people being born from generations that were born during high fertility, when still China had high fertility because economic development was not still going on at that time, and the one-child policy was not implemented. I emphasize both because demographers usually have this debate, but both things, they influence the fertility decline. Economic development, people moving to urban areas is more expensive to have children, so on. People decide to have fewer children. And then the government imposes the one-child policy, people also start to have few children. So it's like the two things acting together. And then now the government is concerned with the population aging in so big numbers as the population of China. The European Union experienced fertility declines really strong as well. That's the left, also 2010, and how it's expected to be by 2050. Because of that, there were many policymakers saying Europe should influence immigration, should not influence, should actually try to bring more people from other countries to work in Europe, because when this cohort here reaches working ages, you're going to have a really small cohort of people working, while these people here are going to be dependents in older ages. So some demographers saying, oh, European countries should actually bring immigrants to work and in their countries to sustain the older population in Europe. Some European countries, Eastern European countries, and even Portugal, Spain, and Italy have really low levels of fertility, exactly because still a lot of gender inequality in terms of who takes care of children, and not enough support from the government in terms of childcare and so on, even with maternal leave and paternal leave, much better than what it is here in the US, of course. But having children is still really expensive. So fertility declines a lot. And So some demographers suggest immigration could be a solution for that. You can bring immigrants, they will work for the country, and that will stimulate the economy of those countries. But of course, there is a lot of pushback, discrimination, racism, xenophobia against immigrants. And some discussions more recently have been saying that still female labor force participation in some countries is still low, even in Germany, for example. So you have to influence women to go into the labor market. But influencing women to go more to the labor market, if you have gender inequality, fertility will tend to decline a lot because all the burden of taking care of children will be on women. And also, another discussion is that in European countries, because of public school, people usually stay longer at universities, go to grad school and so on, and they take more time to enter into the labor market. So there is a discussion about like how we can stimulate people getting out of school and going to the labor market. It's not a matter of privatizing universities in Europe. It's more a discussion of how to implement some policies that would incentivize people going to the labor market earlier than what they have been going on average. So a lot of policy discussions are done because of age and sex structure. Understanding age and sex structure, doing an appropriate projection of the age and sex distribution of population, not a simple thing that we saw in the previous slides, but a serious projection of the population will tell us what the government will need in terms of supporting older people that will increase in retirement ages, and we will need fewer resources for education, for example, fewer children, and so on. We understand our needs for the future, okay? And this is the projection for the US. Also, the population getting older and then getting a little bit more rectangular shape, but it's still the US, as we're gonna see in the next chapters, among developed countries is the one with the highest levels of fertility. Because you still have immigrants coming to the country. Immigrants usually have more children than the US born population on average. And in specific groups in the US, even US born, they have higher fertility than others. Usually more religious groups, they tend to have higher fertility than others. So the US, because of cultural and immigration aspects, still have higher fertility than other developed countries. And you don't see a dip as big as we see in European countries here for younger ages. In the US, you still have a lot of people being born, okay? Even in absolute numbers. And this is just an example to show how when we break down populations for really small areas, we start to see completely different age and sex distribution of the population. This is the Llano County data from 2013, just west of Travis County here. So Austin's right here, so Llano County. And this specific county with a really older population, a really old and sex structure, right? A really old age structure of the population, both for men and women. And really few people in ages like younger ages, in college ages, and young professionals, okay? On the other hand, when you look at Brazos County, you see the opposite. Because of Texas A&M, because of Blaine College, all these different institutions here, you have a really big number of people between 20 and 24 years of age, much younger age and sex structure than we saw for Llano County, right? So, and when we do projections for small areas like this, thinking counties as small areas is much harder because the age and sex structure is not so regular as we see for bigger areas like countries. And any specific small changes in fertility, mortality, and migration can change a lot the age and sex structure of these places, right? And so whenever we are doing projections for smaller areas and considering counties as smaller areas, it's harder to think how the population is going to be in the future, right? Because again, small changes in fertility, mortality, and migration can change a lot the age and sex structure of this population. I want to show before I talk about age. I think, yeah, let me just show here. This file here, this Excel age sex structure file is compressed in the website, in the course website. And if you download it and uncompress it, you're going to have some examples of graphs using demographic data and some other kinds of data. So this bar chart here, under the subfolders, the age sex structure in Brazil. So I just show how you do the age sex structure graph in Excel, right? So let's say that you collect information from any place. It can be for a county, it can be for Texas, it can be for any country. And you get it for a specific year, both for men and women, and you break it down by age groups. For some areas, you can have 80 to 84, 85 plus, or you can go even to 100 plus, right? For every 5-year age group until 100 plus, depending on the data that you have available. What we need here is pretty much these two columns: the population by age and sex, male and female in a specific year. And then using this data here, we just get the population in each one of these cells and divide by the total population in the country in that specific year, multiply by 100, we have 7.4% of women of the overall Brazilian population. Of the overall Brazilian population, 7.4% were women between 0 to 4 years of age in 1970. The same thing for men. This number divided by the sum of this one plus this one, multiplied by 100, we have 7.55 men. Same thing that we saw before, a little bit like the sex ratio at birth, a little higher than 100%, so more men than women. In order to do this, this graph, we have to put one as negative and the other one as positive, so they go into the two sides of the graph. So women here, I just put as negative in the beginning. This number here is multiplied by -1 at the beginning here. And for men, it's not. And it's just the way that it works in Excel, and it's a little tricky. Usually these age and sex structures put men on the left and women on the right. And in this case, I had to put actually women negative, men positive, and then afterwards invert the bars, put women from the left to the right to be as the standard of demographers. Why I did that? Just because then this blue and red appears in the same order as in the legend here, blue and red. So there's little tricks that you might find in specific software that you use, right? So I just did women negative, men positive, so they were the opposite in the graph here. Women were here, men were here, and I inverted, and it shows in the same order as in the legend here. And I just used data from 1970, 80, 91, and 2000. That's just an example, because if you have a specific county, state, or country that you want to do your own age and sex structure graphs, you can just enter the data here, and it's going to be generated automatically. So that's for 1970, 1980, 1991, and 2000. Also the population getting older, okay? The other graphs here, this histogram is just the population of the US So it's not the age sex structure. I think I just did the age structure, right? Yeah, just the age structure. It's kind of the pyramid, but instead of separating by men and women, all together in vertical. It's the same thing, right? Same idea, but not broken down by sex. This one, and here we have a lot of different ones. Age-specific fertility rates, infant mortality rate, just some examples of how you can just get some data in public websites and create your own graphs. In Excel, it's cool that you can create and can change the colors really easily. It's easy to learn instead of more complicated statistical software packages, okay? If I'm using a big micro data, remember what micro data is, the data for each person that was interviewed in a survey, I have millions of respondents, several variables. I usually use a statistical software. But for this one, that the data is already aggregated, we already have a table, I just use Excel. It's faster, okay? Yeah, so just some examples here. And before I go into the dependency ratio, I'm just going to show you, go back to the slides. So a really popular measure in demography is the age dependency ratio, right? So the total dependency ratio, to be more specifically, is really widely used by demographers to be a summary of how the population in a specific country, in a specific year, is structured in terms of age groups. So it's pretty much the division of the dependent age population by the working age population. Of course, in some countries, even people below 15 years of age can be working. You have a lot of issues of child labor in more developing countries. And also, in several countries, people work even older than 64 years of age. But overall, what this measure tries to do is to get the number of children, those between 0 to 14 years of age, and the number of older people, those with at least 65 years of age, add them together and divide by the working age population. So we have an idea of how many dependents, how many children, older people depend on the working age population. Right? Because the working age population is the one producing the goods, the resources, paying most of the taxes and everything, and they will sustain the young population and the older population. And it's usually multiplied by 100 to analyze in percentage terms. The higher the ratio, the more people each worker has to support. Higher the ratio, we have more children and more older people compared to working people. So more people to support, more dependents to support. The lower the ratio, the fewer the number of dependents. When you have proportionally fewer children and older people in relation to working age people, then you reach a time in your population which you have a lot of people working, and that can generate economic development if you have the reasonable structure in your country in terms of job opportunities, educational attainment, high educational attainment of the working age population. Again, a simple measure can bring us into a lot of debates about policies that we have to implement to a population. We can also subdivide the total dependency ratio into the youth dependency ratio and old age dependency ratio. The old age dependency ratio, also known as the aged dependency ratio. The youth dependency ratio is pretty much just the number of children divided by the working age population. So the numerator is the population of 0 to 14. It's only these guys. And the old age dependency ratio is only older people divided by working age. So only people with at least 65 years of age divided by the working age population. So the working age population is the same for both youth. The denominator of the youth and old age dependency ratio is the same in both ratios. And again, remember, why is it called a ratio? Because in a specific year, a specific country, people are either classified as children, as being working age, or as older people. Right? I'm in a specific age in each year. So I can just be one of these three groups. So I'm analyzing, I'm comparing the size of different age groups, the age groups of children, older people, to the size of the age group of working age people. So I'm comparing two different subgroups of the population. When I compare two different subgroups of the population, I have ratios, not rates, right? Rates is when my denominator is measuring people who have a chance to experience the event being measured in the numerator. That's not the case of ratio. The ratio is subdivided population in different subgroups, and I compare the size of one in relation to the other. And if we add the youth dependency ratio to the old age dependency ratio, we have the total dependency ratio. And here, just to show variation across different countries, and this is data that it's available in the textbook, I mean, going back to 2014, but just to show how there is variation across countries in terms of youth dependency ratio and old age dependency ratio. So for example, here in African countries, overall, they have higher total dependency ratio. So they have more children and more older people together in relation to working age population. And countries such as Macau, South Korea, China, Russia have smaller total dependency ratio, fewer children and older people in comparison to working age people. But then if you break it down, you gain more information about it. These African countries, what you're seeing is a really high level of fertility. When we have really high fertility, the number of children is really big when you compare it to the number of working age people. In these countries, still mortality is high, so not as many people reach older ages, right? So what is driving total dependency ratio in these countries is not that you have a lot of people working in older ages, is that you have a lot of children. So a lot of children, fertility is still high. Of course, data from 2014, fertility is still high, and mortality is still high. So you still don't have as many older people in comparison to working age people. And in these other countries, you have the opposite. You start to see a decline in the number of the youth dependency ratio because fertility is decline is smaller. And this differential here, 20.5 in China to 16.4, is still high for youth dependency ratio, but this difference is not so high as we saw here for Niger, Chad, Uganda, Gambia, for example. But for Japan, that has low fertility and people living until older, really older ages, then you start to see the opposite trend, higher old age dependency ratio in comparison to youth dependency ratio. With these three numbers here, you start to see that the policies in Japan should be concerned with the higher percentage of more older people in comparison to working age population. Italy, you also see that because Italy also experienced really huge declines in fertility in these last decades. We usually see this TV series with Italian families, big Italian families, a lot of children and so on, but real data, Italian families are smaller now, right? Fertility decline in Italy as well. Here is only the youth dependency ratio, only the youth dependency ratio for several years in China and in the US. So only two countries, only the youth dependency ratio, but the data for several years. And you had, for example, that in around 1970, you had 70 children for every 100 working age people in China. So really high youth dependency ratio. And in the US, that number was around 46, 47 children for every 100 working age people. But this difference between the youth dependency ratio in between China and the US started to decrease. And then in more recent years, actually, proportionally, there are fewer children in China in relation to their working age population compared to the US, right? Exactly because fertility declined so much in China in these last decades. And then we start to see that in more recent years, okay? And you have projections up to 2050 in this graph. On the other hand, you have the age dependency ratio, the old age dependency ratio. The US had more older people in comparison to their working age population than in China. So back in 1970, around 15 people with at least 65 years of age for every 100 people in working ages in the US. And in China, only around 8 people with at least 65 years of age to every 100 people in working ages. And because China now with low levels of fertility, people start to get older, get into working ages. And the older these people get, even previous generations that had a little higher fertility get older, proportionally, you're gonna have more older people in China in comparison to their working age population in relation to the US. So we're gonna reach around 37 here compared to around 32, 33 in the US by 2050. Of course, those are projections, can be a little off, but that's the overall trend, okay? This is for Brazil. And here I'm showing the same graph, the youth dependency ratio, or the child dependency ratio in orange, the old age dependency ratio, the purple, and the total dependency ratio in black. And then we see that in previous years, this high level of the total dependency ratio was pretty much driven by the high numbers of children in relation to working age people. And as fertility starts to decline in Brazil in the 60s, 70s, 80s, and so on, you start to have fewer children. The child dependency ratio declines in relation, so number of children in relation to working age people declines. This one, the total dependency ratio also decline. But then people start to live longer, mortality declines. Population starts to get older, more older people in relation to working age people. The old age dependency ratio starts to increase. And then that's exactly what Brazil is going to experience in these next years. So here we have, right now, in this moment, 2022, the lowest levels of total dependency ratio that Brazil will experience for several decades. So what does it mean? That at this moment here, this specific time point here, this range of years, you have fewer dependents in relation to working age people. You have fewer children and older people in relation to those who are producing. If Brazil has a good education system that provides college education to the population, when they reach the ages of working and there are good jobs for them, there is economic development, then demography will help economy. But in order to demography to help economy, you have to have all these pieces together, right? More equality in the labor market for men and women, for all the different race, ethnicity groups, and so on. So right now, Brazil is passing through this window of opportunity, what demographers call the demographic dividend. So if you just Google demographic dividend, there are a lot of papers being done about demographic dividend for several countries. Also called as demographic bonus by some demographers. But the idea is that in this specific time point, there is a window of opportunity. You have fewer dependents in relation to workers. So you have more workers as you could have, right? And there are some studies that were done about Southeast Asian countries that show that because of their fertility decline, they reached this window of opportunity earlier than Latin American countries. They reached them in the 90s. So a lot of the economic growth that the Southeast Asian countries experienced, one of the factors that helped was demography, was this window of opportunities, the demographic dividend. But the difference is that the Southeast Asian countries, they have much higher education attainment than Latin American countries. And they had a much more productive economy going on. Brazil experienced a huge increase in the number of people reaching, having college degree. But it's still in Brazil, the percentage of people with at least college degree is only 13%. It's really, really low. What actually increased a lot in the country in the last years was more the percentage of people at least finishing high school. Finishing college is still low. And since 2016, with all these different political changes that happened in the country, with impeachment going on and all chaos in terms of politics going on in the country, right now, during the pandemic, the recovery, a lot of countries are experiencing economic development, economic growth. Brazil is not. So we are in a time that we could take advantage of the demographic composition to increase economic development, and we are not because of all these different political and economic aspects that the country is experiencing. A simple graph, you can start to think about policies. And if you don't create these aspects in order to take advantage of the demographic composition, you're going to have a problem into the future. Because people are getting older, total dependency ratio will increase, and then you're going to have more pressure in the retirement system. That's what some demographers call demographic onus. I really doubt if you Google demographic onus, you're going to find it. This demographic onus and bonus is more to just make a play with words here. What you usually hear is a demographic dividend, right? And you can find a lot of literature about that and a lot of studies for specific countries, right? And here in the same in that same graph, in the same Excel file, I also generated with the same data that I had before for 1970, 80, 91, and 2000, this other graph with dependency ratio. In this case here, the total dependency ratio is the sum of the youth dependency ratio, the light blue, and the old dependency ratio, the dark blue. So the total dependency ratio is the sum, the total height of these two curves. So you can show the dependency ratio in a graph format in different ways, just to show that, right? And in here as well, here is data for Brazil, but with like some projections up to 2050. Is it 2050? Yeah, up to 2050. And then you see that child dependency ratio, the light blue, has been declining over time. And the old age dependency ratio, the dark blue, increasing over time. And right here is the window of opportunity that the country has that is not taken into account. In terms of the population is getting to working ages without higher education, without a college degree, and it's still a lot of people being unemployed. So from here, you kind of see really simple graphs, really simple data, age, sex structure, dependency ratio. You see that you can understand the history of countries. And if you have appropriate projections, you can understand what that country will need in terms of policies, okay? So it's 12:25 now. And quiz 3 is open from now until 8 p.m. tomorrow. Don't take it in the last minute. Some people have internet issues, and I will not reopen because of those problems, okay? Thank you very much, and I see you guys on Thursday.